Hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our pattern wise DSA sheet, and in this we were doing linked list. Today we'll start the third pattern of linked list, which is reversal pattern, and we'll do the very first question, which is reverse a singly linked list. So let's read the problem statement. It says you will be given a linked list and we have to reverse it. As you can see, after reversal the head will become the tail, means one was the head earlier, so it will become the tail, and now earlier the 5 was tail and now the 5 will become head. So we have to return head, new head, which is 5, such that when 5 will get returned, linked list will read in reverse order. So let's see the constraint. Constraint says the number of nodes will be from 0 to 5000. 5000 means 10 power 3. So anyhow, in this case n squared solution will also work, but as we already know that in linked list we rarely solve problem using O of n square time complexity, but mostly it will get solved using extra space complexity or O of 2n 3n as brute force, and exactly O of n or n by 2 sometimes without extra space as optimized approach. So let's see how can we solve it. In linked list we have learned few patterns which are basic operations, fast and slow pointer, correct? Yes. And reversal pattern, which we are going to learn now, merge and sort pattern, merge and sort pattern. So in this case, as you can see, the name itself says that we have to reverse it, so we can think of reversal pattern approach, but that is the optimized approach. How can we think for the brute force approach? Suppose this was not linked list, suppose this was array. Okay, so suppose this was array, means we will have 1 4 3 5 and 2. Okay, so if we have array and we have to reverse this, what we would have done? The very first approach is using the 2 pointer approach, means left pointer will point here and right pointer will point here, and then we will swap both. So it will become 2 and then 1. Now we'll move our left pointer ahead and right pointer behind, correct? So when we will swap it, 5 will come here, 4 will go there, correct? And now again left will come here and right will come here. So as they both are pointing to the same index, it means swapping does not make sense, so we will stop. So 3 will be as it. So can I say this array has been reversed? Yes, but this is so linked list. In linked list we cannot, if we will start from this and this point, correct? So left pointer to can move by current dot next, but right pointer, if we will do current dot next, then it will move, go ahead, it will not come behind. For that you have to reverse the half part, correct? So it means we have to apply the reversal technique in the left half, but as of now we don't know how to reverse. Then what is the second brute force approach? Second approach will be read whatever is there in the linked list form and put it in the array. Done. Now again iterate from the head of the linked list, and this time read the values from the end of the list where you have stored the values of linked list. So now this is 2, correct? So overwrite this with 2. Now move your current to current dot next and your pointer at 5. Now overwrite this. Now overwrite this. Now overwrite this, and now overwrite this. So yes, I can say I have reversed the whole linked list now. But what will be the time complexity? The very first O of n we took to iterate and insert all the values in the list. Second O of n iteration to again go and overwrite all the values so that to reverse it. So in total O of 2n time complexity, and space complexity will be O of n. Why? Because we have used extra list to store the values of the linked list, correct? So can we write the code for it? So I have written the code for you. First we will create the array list, and we will make alias of head pointer. Until the current become null, we will keep adding all the linked list values in the list and keep moving our current ahead. Once done, again we will restart our current from head, now this time to overwrite the values to make it reverse. Now we will run the for loop from end position of the list, and one by one will come back and we will override the current value. So current is moving from left to right, means 1 2 3 4 5, and list values we are reading from the end side. So in this way, by using this extra for loop, we will override the values to make it reverse. and at the end we have not moved our head, so head will be our final answer. So let's run the code and let's submit this. Done. But can we optimize it further? Means, can we write in just single iteration instead of 2n? Yes. So you saw na, in linked list O of 2n means 2 iteration solution was brute force and optimized will be single iteration, correct? So let's think. So in single iteration, if we have to reverse, for sure we have to change the next pointer address. Can I say that? Yes. So if we don't want to come back, definitely we have to change the pointer. But how it is possible? It is possible when we will be standing on this as current node, this as next node. So if we have, like, our current is pointing to this 4, can I say? But I want to point it to what? Null in the first case. Okay. So let's make null and let's name it previous. Okay. Let's name it previous. Again saying 1 is pointing to 4. I want this next to point to this. I can make it. But if we will not save this 4, definitely we are going to lose the entire linked list. So hence it is very important to save this in a next pointer. Okay. So can I say whatever we just did, we have to write. So we have to start our previous with null. Okay. Current pointer with head. Done. And now the next pointer as current dot next. So now current dot next, which is 4, from the entire linked list we have saved in the next variable. So now if we will move this current dot next anywhere, we are not going to lose our linked list. Done. So what will be the next code? We have written current dot next, we have saved in a next variable. So whatever has been written in the right side, we have to fill it now. Means current dot next we have saved. So we have to write now current dot next. What new current dot next we want? Can I say the new current dot next we want whatever previous is holding? So in this case previous is holding null. So anyhow 1 dot next after reversal we want it to point to null, correct? Done. Now what has been filled? Previous. So now the next job is to fill previous. Like what will be the value of previous we want? So earlier it was null. I want to fill previous. So what do you think? Next time the new previous will be, can I say current? Yes. So current. Now what has been filled now? Current. So what should be the next? Current. So we have to fill current, 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 current. But current we have to move. How we move current in the normal linked list? Current is equal to current dot next. But if in this case you will write current is equal to current dot next, you are thinking ki it is pointing to the next. No, you just have changed your current dot next to previous. So now this array is not existing anymore, it is pointing to this. So if you will move current is equal to current dot next, you will again point to null, which we don't want. We want to move our current at this position. So where you have saved? In the next variable. So hence current is equal to next. Now if you are thinking ki next value has been inserted, so next time we have to fill this next variable. So see, that's what we are doing at this line. So can I say this is the entire code which will reverse our whole linked list? But not one iteration, we have to do this again and again. So we have to close it in a while loop. Can I say that? So we have to close this in a while loop, while. But what? For what? As you can see, current is moving ahead. Let's say till what? So next time, can I say, as we have written our code, so this will become previous, this will become current. Again, next we will save current dot next, which is 3. So 3 will be having next. Done. Now again current dot next we have to point it to previous. Previous is having 1. So I will revert this to this. Done. Now again we have to move this previous, current and next. So what we will do? We will move, we will make this previous, we will make this current, and this will become current dot next, which is next. Done. Again we have to reverse this. So reverted, previous done, current done, next. So again we have to move this all, correct? So let's move this all 1 point ahead. Done. Okay. Now this will be our next. Again current dot next, this we have to revert. Okay, so this will be removed and this will get attached. Again we have to move our current, previous and next. So current will be pointing to this. Okay, ठीक है. Now current is pointing to this and next is pointing to null. Do you think we should stop? If we will stop, so as of now we have not connected this to next to this. So can I say I have to run for one more time? So for sure the while condition will not depend on next. Can I say that? Now again this will get connected to this. Anyhow next is null. It's okay, next is null, but this will get connected to this. Okay, done. And now next is null. Okay, now one more point, we have to move this ahead. So previous will be pointing to current. Done. Current is pointing to null and next is already pointing to null. So we should stop now. So what should be the stopping condition? Can I say until my current become null? Yes. So in the while loop we have to say while current not is equal to null, keep doing this. Keep doing this. Now if you are thinking we could have written the condition for previous also, na, ki while previous dot next not is equal to null. See, we have not written this because if you remember at the starting condition our previous was null. So if we will write previous dot next, it will become null dot next and this will give you null pointer exception. So hence we cannot depend on next, we cannot depend on previous, but the while condition will depend on current. Until it becomes null, we have to keep doing this. And this 4 line of code will help us to reverse our linked list. But what should be the head point which we should return? As you can see, now 1 is not the head anymore. If you will, because head is still pointing to this now. So if you will return this head, you will get 1 and null, not entire linked list. So if you want entire linked list, this previous you have to return because this is the new head. So after coming outside of this while loop, you have to return previous node as head and you're done. So this is the code which we have discussed. Previous and current we will start, previous null, current head, and keep doing this, the 4 line of code, and after coming outside you have to return the previous pointer. Okay, so let's run the code and let's submit this. So if you understood, this was the code in Java. Okay, and the time complexity will be definitely O of n because we have solved this in just single iteration, and the space complexity is constant because we just have used 2 different variables. Okay, so this was the Java code, and here is your C++ code with the similar approach, optimized one, and here is your Python code with the similar approach. So if you understood this, definitely you can go in the sheet and mark the very first question of this pattern as done. And that's it for this video. Let's meet in another video with some more interesting questions and topics. Till then, keep learning, take care of yourself and your family too.